Good day, grade 9 science students. Today what we're learning about is conductors and insulators. So we're going to explain how conductors and insulators work. What are they, how they work, and how some objects can even build up a static charge until it releases that charge as electric discharge. We're going to explain that today. So we're going to learn that conductors, they have this ability to allow electrons to move freely in them. If you look at a wire, the metal part is the conductor, while the rubber part is known as an insulator. Okay, and electric insulators are materials that hold onto electrons and do not allow them to move easily.
Metallic solids are called conductors. Can you name a few metals found in wires? Pause the video and continue when you are ready. The correct answers often include copper, silver and gold. The latter two are not used often because they are very expensive. There are other metals that you could have listed. If you look closely at the structure of copper, it has a positively charged lattice of metal atoms surrounded by loosely held valence electrons. This is a bit like the covering of a pie, except the lattice that's on the top would extend all the way through. The loosely held electrons are free to move randomly in a metal, but once a battery or source of voltage is applied, the electrons flow in one direction, generating an electric current in the metal. Some materials offer hardly any electrical resistance to the flow of current, or the movement of these electrons. These include some pure metals and metal oxides, cooled to a few degrees above absolute zero. These are special conductors called superconductors. Some non-metal conductors like graphite, a form of pure carbon, or solutions of salts forming electrically charged ions will conduct electricity, but these have more resistance. Most other solids have tightly held valence electrons, which may be locked up in chemical bonds. Some examples include solid salts, ionic substances like sodium chloride, sulfur, an element, polythene, a polymer, and glass. The electrons in these examples are not free to move, and so are non-conductors. What is the other term used to describe a non-conductor? The correct answer to describe substances that do not readily conduct heat or electricity is an insulator. Did you get it right? Here's a challenge. How can you get an electric shock? You, after all, are an insulator. Pause the video and think about this. When you're ready, please continue. The answer is that an electric shock occurs when an electricity source with a large voltage causes a sufficient current to enter and exit the human body through the skin, muscles or hair, all insulating materials. In summary, metals contain lattices of positively charged ions. The electrons are loosely held and are free to move between the metal atoms. When a voltage is applied, a current is able to flow. Some materials, like pure metals and some metal oxides, when supercooled, are exceptionally good conductors. These are superconductors. In an insulator, the electrons may be more tightly bound to the atom or held in a bond or bonds. This makes them less mobile, and so the electrons are not as free to move. These materials act as insulators. Examples include most non-metals, solid ionic substances, plastics, you, and me.
So for your note, conductors are materials that allow electrons to move freely. Examples of conductors would include most metals, okay? And they allow electrons to change position, and they're called conductors. Conduction itself is the movement or transmission of electrons through a substance. Metals, all metals such as excuse me, copper and aluminum, they have free electrons that allow them to move. That's my cat. Did you hear my cat over there? It's making noises like crazy. Electrical insulators, they hold on to their electrons and do not allow electrons to move easily. And examples of that are most nonmetals. So an electrical insulator is a solid, liquid, or gas that resists or blocks the movement of electrons. Dry wood, for example, glass and plastic are all insulators. And an insulator can hold a static charge because the static charge remains in place. So generally a good thing that holds a static charge is something that is an insulator because the electrons stay in one place. until that electric charge reaches so great that it actually discharges those electrons. That's the second part of our learning goal, is understanding that insulators actually can hold a static charge better than some conductors. So, electrical insulators and conductors. So the materials that allow some movement of electrons are known as ferroconductors. They do not allow for free movement of electrons, and they're not quite held in place as an insulator. They're in between. So we have some things that are ferroconductors. For example, ferroconductors would be like water with dissolved minerals, for example, that actually can conduct electricity. Rubber is an insulator for sure. Excuse me. Moist air. My wife just laughed at me there. Moist air is a ferroconductor. That means it can conduct some electricity. Human body is a ferroconductor as well. Mercury is an example of a conductor for sure. So if you look at all these metals, they're conductors. In the middle we have ferroconductors like carbon and soil, conduct some electricity. And finally we have our insulators that don't conduct electricity at all. So when we think about water, water is actually a conductor. Now, pure water is actually an insulator. But the water that we deal with in everyday life, including coming out of your tap and the oceans and the lakes, that actually is it's actually a weak conductor. It's a ferroconductor. So if you're ever in the water, for example, you want to get out of there because, first of all, you are a big bag of blood, which has salts in you, which conducts electricity. And second of all, the water that you're in the lake or the ocean, has lots of salts dissolved, and it's a ferroconductor. So if lightning was going to hit the ground, you would get electrocuted and die, unfortunately. So as well, you don't want to put out an electric fire with water because it can conduct electricity. And finally, if you are operating an electrical device with wet hands, it conducts electricity into your body. It's not an insulator. That's it for today's lesson. Hope you enjoyed it, and we'll see you tomorrow.